connected. Okay, Restream thinks we're connected. Twitch usually is the first one to follow. And Twitch thinks we're connected. And YouTube is almost there. And YouTube thinks we're connected. Excellent. Welcome to Code Hangout number 191. And the first stream of the new year. How is everybody? Just finishing off my coffee. So today I'm looking into something that I've been bouncing around my head for a while. And it's basically, can I get rid of this? There's some, okay. It's basically, I want to use the promo space at the end of a puzzle to show things like when I'm streaming. I'd like to, right now, I'd love to, for people who are solving the puzzle right now, to see that. But because of the way the information about these promos is loaded, it's loaded basically when you open the browser rather than when you finish the puzzle. That is currently not possible. So I want to change that. And I also want to move the algorithm that figures out what to show to the server. So I can basically, press a button, say, I'm going live with a stream. And then from then on, while I'm streaming, people who solve the puzzles see, hey, if you like this stuff, if you have any comments, if you've encountered any issues, if you want to talk to me, you can do so right now on YouTube or whatever. And then once I'm done streaming, that promo no longer will show for people solving puzzles after that point, no matter when they open the browser or when they start it. And there's a couple of things over the years that have sort of accumulated that happen at the end of a puzzle that are currently a bit of a mess. So for example, we're incrementing the solve counters. And that's a completely independent system that doesn't write to my puzzle database, and it's not associated with the puzzles, and it's an old system. And I'd like to move all of these into a single thing. So when you finish a puzzle, before the dialog pops up, it talks to my server and says, hey, I finished the puzzle. And then my server says, okay, let's increment the counter. Let's check if I want to show you any kind of notifications, etc. And in the future, I'd like to also use that for things like, hey, here are some cool puzzles. Do you want to, have a look at any of those things? You want to play another puzzle like this, etc. So let's write some of these points down. So API call, and I think I've put some of these things here. Puzzle completed survey API, right? So let's actually put this here. So we said refactor counter updates into API call and update puzzle API to handle these counters. Let's put this over here just a second so we can kind of write this in my style over here. Send progress counter server and handle promo selection on server and return from API call. So I want to add some information. So for example, one of the bits of information that the promo system uses to decide what to show or if to show anything at all is the number of solves that are recorded on the machine, right? So basically, let's see, if I go to, let me see, do I have a puzzle that I solved? Let's open, let's just open anything. Yeah, so let's go on SudokuPad app. So if I go here, in fact, I should get a notification right now that I'm running out of space. That means I have a whole bunch of puzzles there, right? So there is a system, and I think it is features dot, I don't remember. Is it the puzzle counter feature? There's a feature where basically it just opens the local storage because currently all your solves are stored in local storage under these keys progress underscore, and that's one for each puzzle basically, and it stores your progress. So when you finish a puzzle, well, it's mostly designed for letting you continue a puzzle, right? But of course, once you finished a puzzle, I don't actually know if this marks it, but anyway, I'm just counting how many of these replays there are to get an idea of how experienced the puzzle solver is, right? So certain promos won't show to brand new players, certain promos won't show to really old players, right? So for example, this avoids most of the time that a YouTuber would get a promo showing in the middle of a video and things like that, right? It's basically the only targeting I do, right? And it obviously is no personal identifiable information. There's nothing stored in the servers, yada, 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 right? Let me just remember, it's not, I want to say the word API call, but obviously it's not an API. I don't know if it's under solve counter or if it's on framework directly. Might be on framework. Is it get? I don't even remember. Progress? Get progress count, I think. So get progress count. And the problem is, yeah, so for example, on this account, I have 1,242 puzzles solved. But if I go to something on localhost, it's only 405. And if I go to beta, it's probably also a different number. So if I go here to beta, because, you know, this is per domain or subdomain, 454. Actually more than local. Interesting. Okay. Because that's where I try to do all my my thing. So that's the information I want to send over. Now there is another ID I think that I'm using for the Project 9x9 replay data collection, which I need to get back to. So there's a way for us to, or for me to collect replay data on puzzles for research, which is not happening at the moment. And I'm trying to remember, is this under Project 9x9? Project 9x9. So I'm gonna have to look at a bunch of different features. And that's the other problem, right? A lot of these things were implemented through individual features, but are actually kind of becoming core functionality. So I don't know if I should move them into core or into their own feature or something, or onto framework. Like a lot of the promo stuff is on framework. And I have to see, because I don't even know if the stuff that interacts with the dialogue, that updates the end of puzzle dialogue, is actually there. All right, let's see. This feature, the Project 9x9 feature, I don't think that does the replay research. Replay research. I think replay research might actually be implemented in framework. I don't even remember. Let me see. So on the server, obviously, I have an API call that collects these replays. So let's see what's that API call, and then I can search for whatever is actually looking for that API call. So if I go back to here, search in these folders, and we want to find replay submit. Collect replay. Okay, so collect replay. Oh, yeah. Okay, now I remember. Okay, so this is, yeah, completely different mechanism. So basically, it's kind of part of what I wanted to do in terms of dynamically modifying the data getting served to this client. Because, right, SudokuPad started out as a pure client-side application, right? So you basically got a bunch of files, almost like as if you downloaded a game on Steam or something, and then it just played in your browser. And my server was really just a file server that provided these files. But there's some stuff that obviously needs to interact with other things, you know, like counting everybody solves. Now this mechanism was basically my way of saying, hey, I don't want, since we're doing this research only occasionally, I don't want everybody to download 10 kilobytes of my code that deals with that, when most of the time that doesn't do anything, right? So the idea was that on the server I have a mechanism where it checks if currently research is getting done and if this puzzle load should be part of that research. And then it basically says, okay, also load this file, and this file does a bunch of things. So in the future, I'd like to have more of that, so that you don't download things that are necessary. For example, you know, don't download the fog code for a puzzle that's not a fog puzzle, yada, 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 right? But it's beyond me to do that kind of refactoring quickly. So right now I'm just going to look at all the different places where I do these kind of weird things that might need to get, you know, organized better. This doesn't actually do that much, which is by design. It basically just says, hey, if dialogue no errors, that's basically your end of puzzle dialogue. Then we'll check if we want to pass the replay data forward. And in the future, this might also include a like a permission dialogue, that kind of thing. Yeah, and this one actually sends the progress data, right? So we want to look into that. So it's not this one. The solve counter thing is happening there. Okay, so that's kind of, this is my example of how I'm gonna hook into this thing. All right, so how are we gonna do this? So we'll do, we'll have a hook on that. So steps, hook, dialog, this dialog. 2. We need to figure out, I'm a bit loud in my own ears. We need to figure out if and when and what data to transmit. By the way, if anybody's popping in or, you know, don't be shy, say hello. Always like to know if everything's working well. Don't think anybody's watching at the moment, which is kind of sad. Some of you are there on the YouTube stream. All right, so we'll hook the dialog. Then we need to collect together the information. Because one of the problems is that it might mean, like between finishing the puzzle and needing to show the dialogue, I don't know how much time will pass. Let me see, 1 sec. Let me do this, let me do that. Let me just quickly find a puzzle I solved a moment ago. I think this is a gas puzzle, yeah. So for example, this is a gas puzzle I solved earlier today. I probably want to change the font to the default font. So let's clear this. So when we're starting it from scratch, this is the file that gets loaded for the promos, which currently has James Sinclair's artisanal Sudoku promos in there. And let's clear this for a second. If I refinish this puzzle, it does this twice. That's probably an error. I'm wondering, there's also a bunch of things with caching and so on. But the problem is that the moment I finish it, I want to show the dialogue right away. But obviously, if I send something to the server and then it has to come back, it, you know, depending on the connection, depending on circumstances, it might take a moment, right? Hey, Francesco. Sorry, yeah. I'm just straight. This is my work time. This is not really show and tell, so it's maybe not the most entertaining stream. I definitely want to get started on doing more of those and even doing a few videos, but for now it's I got work done. All right, so we basically hook dialogue, then we'll do send or send puzzle solved notification to server API. So the thing is, at that point, we kind of want to show the dialogue already, which means, but for example, the counter doesn't show instantly. The counter takes a moment to show. Now, right now, it'll be cached, but you see there's a moment. So it actually waits for the server to return that count number. So that count number is already trying to be up to date. So it's kind of the same thing, but not just the count, but also the promo. Return. So we want to return puzzle counter and promo or update dialog with counter/promo. So there's a couple of other things we could do. So for example, in the future, what we could do is include the counter information when you open the puzzle, because it doesn't necessarily need to be up to the second accurate, right? So if there's a counter initially, because right now it just doesn't show anything and then suddenly it pops up. But what we could do is we could show sort of the preliminary with a little spinner, you know, and then when it's finished updating, it just updates and then the dialogue layout doesn't change. And for the promo, we could do something similar, because right now it says support this app. This is basically my own personal promo that's always been there. And that's the thing that gets replaced. So we could change this into something that kind of is more like the other promo. I don't know. We'll have to see. And the other thing is that the other thing I want to change is currently the counters are just updating a number. So right now, let's see if I can find this quickly. So this would be SudokuPad app. No, it's actually under API, right? So it's even in a different repo, and it's a bit of a mess. It's a complete separate microservice, basically. I have way too many of those. So I think there's a file here, counter.json. And I think that one, yeah. Oop, can I? No, I think there's a. I'm trying to remember the hotkey for pretty printing. Edit. Code folding. Let me use it. One sec. Sublime pretty print JSON. I'm sure that I have something. Is it Control H? Control Shift J. Control Shift J. Control Shift H. No. Control P. Control Shift. Oh, no. I think I got the right one. It's just taking this long to do it. I'm guessing it's sitting up there somewhere being busy. No. Because Sublime, unfortunately, is kind of bad at this stuff. It's kind of frozen up. Oopsies. So I found the right hotkey. Oh, Greek. Greek, I need to deal with Greek puzzle names, apparently, because somebody... is that you, actually? I'm guessing it's you. Yeah. You're the one with the Greek puzzle names. God, gosh damn it. The problem is, right, like, there's also puzzle names with Chinese characters in them. So, actually, while we're waiting to see if this is going to decide to crash or finish, let's have a quick look at puzzles without a title. Or can I look at puzzles with a counter ID? No, because I want puzzles with a title, but where the counter ID ends in a dash. So can I say... I was hoping I could say ends with. Contain, well. I mean, they all have a dash in them. Because if I can find puzzles with a counter ID that ends in a dash, those are ones where the title basically translates to nothing. And it could be that, you know, it could be that that puzzle doesn't have a title, but it could also be, let's have a look at the database. I don't actually know if I think I have the puzzle ID also added to the puzzle database now. If we look at puzzle info, yeah, so here we have counter IDs, right? So if I say something like counter ID, and then I'll do regx, right? And then we'll do something like $. Yeah. So for example, here we're seeing a puzzle with Chinese characters in the title. Oh, the counter ID is actually... Ooh, okay. Well, the Chinese characters get dropped as well. So the problem is I might also have to add Chinese. And I think the regex have something for that, but it's not just Chinese. It's Japanese, it's Indian, etc. So there's a whole bunch. We also want to say that counter ID and title is not equal to empty. Does that work? Yeah, so for example, this puzzle has a Chinese title. The counter ID just becomes a dash. Yeah, and there's a whole bunch of these, right? And these are outside of my kind of community knowledge, because I think a lot of these aren't from within people that are on the Discord and so on. There's a whole wide world of puzzle setters out there. But the problem is it's not just those, right? There's probably a whole bunch of other things, right? And then we're back to Unicode and, oh, you know. But I don't want people to break something on my server because somebody's stashing, you know, creating some sort of Unicode bug stash with 60,000 characters of craziness. So, yep, Sublime finished eventually. And it pretty printed this JSON. I have no idea how long this took, but it's horrible. All right. So, the point being, this is how I'm storing the counters right now. And the problem with that is there's no way of saying, like, one puzzle might be more popular than other, but it just might have been released more recently. And, you know, the older the puzzle is, the larger the count will get. So over time, these numbers become more and more meaningless, right? So ultimately, this is not a good way of doing it. And one of the hardest things I'm going to have to deal with is now how I'm going to do something new while keeping the old stuff relevant as well. Like, I don't want to just reset all the counters. So probably what I want to do going forward is, at some point, I'll basically take this number and just add it up, right? The other problem is, if I run both systems in parallel, which is what I usually do, I won't know which count is sort of pre and post sort of new collection, right? If I have two systems of collecting it and there's this difference. Anyway, we'll have to figure that out. One of the other things I want to do is I want to store that information in an SQLite database, not in MongoDB, because there's going to be a lot of it and I want it to be a bit somewhat efficient. So, but, you know, one of the things I want to do with this, and I'm not going to do that here, I'm going to do that on the command line. Let me just close these, close that. So if I go here, let's just write a little bit of code. Under scripts. So if I do src scripts, I'll create a file. What shall we do it? Explore counters.js, right? And then here we'll just say, we'll just have a little async function, right? And then here we'll open the file, blah, 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 blah. The file, can we just require it? Let, or const counter, counter JSON equals require. So if I go from here, do something like this, dot slash blah 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 dp slash counter dot JSON, and this JSON parser should be a lot faster. So if I say something like console.log this, and then I just say explore, yeah. All right, so that instantly opens up and no worries. So what we can do now is we'll do object.entries. All right, because it's a key value object here, so we'll do for const counter ID count of this. We can loop through that, right? And for now, all I want to do is count the total. Total equals 0. Total plus equals count. And total. If I do this, total not a number. If total, if is nan total, let's do this and break out. So if it's not a number, so there's a undefined, okay. So I guess we'll do if undefined count, continue. We'll just skip over it. Undefined. Oh, because they don't get deconstructed into objects, they get deconstructed into arrays. Okay. All right, here we go. So the total is 16.7 million, right? Hi, William Morris. Thanks for your use. I really appreciate it. Some spacing. Oh, that's super vague. But yeah, I mean, if you have like a detailed description, or if you have like any kind of sketches or something, it's probably easiest if you either post it in the Discord chat or send me a quick email. But yeah, I definitely want to improve usability on mobile devices, and that's something I'm definitely going to work on very much early this year. So feel free to let me know. It's not the focus of today's stream, and obviously the more detailed you can be and the more specific, the better. But also remember, I need to build something that works for various computers, devices, and so on, and I unfortunately don't have the bandwidth to customize things for specific devices. So the more generally applicable these suggestions are, the more likely I'll be able to make these kind of improvements. Like this puzzle without scrolling. Well, the scrolling, I guess, depends on your interface, right? on your screen size. So, you know, if I make it slightly shorter, it might work for you and might not work for somebody else, and then somebody else puts it sideways. So it's not really something I can guarantee. Because obviously there's like an infinite number of different kinds of screen sizes and layouts out there. But yeah, that whole dialogue needs to be improved, that's for sure. But that's one of those complicated things. To be honest, the whole user interface needs to be updated. And that's definitely something I want to do, but that's going to be a big task. Why did I do this? I wanted to do something specific. Yes. Okay, so we want to need, so we want to have total and ID count. Right. We just do blue counter JSON. We'll just say let counter data equals that. Right, and then we'll just ID count. So it'll be just the length of that. Need that. So if I do that, so we have 59,498. Let's do a quick. How do we calculate the median? Calculate median. So I can calculate the average, but it might not be so useful because we might have a lot of data points is odd. The median is the middle data point in the list. It's even. The median is average. We could sort these. So if we'll do counter data, if we sort it, dot sort. I don't think. If we sort it by A, B. A1 minus B1. It'll be sorted that way, right? And if we do if we take this over to we do something like this, right? And then we'll do that, and we'll take the item at that index out of that array. I'll just say something like let median IDX equals this. That. Okay. Median is 6. So there's a very long tail, in other words. So what I'm trying to say is that very few, relatively speaking, few puzzles. I mean, we're still talking thousands, right? Relatively few puzzles account for the vast majority of solves. So what I'm trying to figure out right now is, okay, over time, how much data, like, let's say if I have a certain number of bytes per counter increment, like it's, incrementing a counter is easy, but if I want to record some information with each individual counter increment, i.e. when it happened, to be able to do graphs over time, then I have to record that information. Now, I can obviously, you know, do what's called bucketing. So, for example, I could count puzzle solves per hour or per day or per month or whatever. But if I want to kind of conserve the initial information, ideally each solve would be an entry in a database with basically a date and a time. And the date and the time is probably going to be 64 bits, right? So now instead of storing, you know, 64 bits for puzzle, I'm going to store 64 bits times 10,000 or times 16 million or whatever, right? So if I take this number, 64 bits is, how much is it? It's 34 bytes, so it's 8 bytes, right? So if I do times 8, right? And I'll divide that by 1024 times twice, right? So that's 127 megabytes. So that's not really bad. So that's, let's say, for a year. So if every year it creates 127 megabytes of data, that's fine. The thing is, there's going to be a bit of overhead. So it's not purely this information size. So there's probably going to be something else. And ideally, I'd have additional information, you know. So we'll have to see how it goes. But it's my excuse also to set up SQLite, which I've been experimenting with, but I hadn't really run. And I think it's going to be a first class member of Node here, but it says experimental. So let's first see database. So Node.js 23.5. I don't think that's the version I have. So I'm at 22.11. So I doubt I have SQLite yet. So if I do this, will this even run? No such built-in module, Node SQLite. So do I have to add like an experimental flag, or is it just not available in that version? Experimental SQLite flag. So if I do this, okay, so that works. I probably don't want to do that though. Okay, so is it still SQLite 3? Because that's what I used to use. And I don't know if this is still the go-to SQLite Node.js module. Normally SQLite binding for straightforward, blah, 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 version, blah, blah, blah. Latest update 2 months ago. Issues 2 weeks ago. It's not seems super. Okay, so best SQLite for Node. Better SQLite 3. Classes in the library for transaction support, high performance, efficient safety. Seems to be more modern. Because SQLite 3 is. Why is it still 3, right? Like you'd think this would have updated. I mean, it doesn't say anything about deprecation, but sometimes even these pages are very, very old. SQLite has moved. No, for multi-threading, 3 weeks. I mean, a couple weeks ago, November. I mean, it could be just because it's stable as well. Doesn't say anything about releases. Let me just look at the better SQLite on npm. npm better SQLite. What does that say? Fastest full structure support, high performance efficiency, 11.7.2. All right. I mean, faster is nice. All right, let's try that. This is gonna have to run on the SudokuPad server. So let's switch to there for now and start experimenting a little bit. Do we have, probably have SQLite already installed here. No. Okay, let me, before I install it, let me check what the repo looks like, just to make sure I don't get myself into some trouble. All right, yeah, that's fine. All right, so let's go there. npm install save better SQLite. Or is it better SQLite 3? Ooh, better SQLite 3. Let's make sure we get that right. Why is it taking so long? Better SQLite 3. Come on. What? Okay, installed without any output. That's very strange. Okay, let us do a little bit of test because I haven't done SQL in a long time. So let us do something here. Touch test SQLite.js. Right. All right, and if I do something like this. Ooh, I don't like this. Yeah, SQLite. I do this, right? And we'll do something like this. Options. What are the options? Okay, what are the options? There's something kind of reasonably better. It's probably cannot be reasonably come to SQLite 3 in general. For example, if you're executing queries that take 1 second to complete and you expect to have more concurrent users executing it will save you from SQL serialized nature. Version SQLite is very, very fast. Yeah, we'll definitely need to run some tests. Excuse me. We'll probably want to run, like, add 16 million records to a database and try it and see how big it gets. The other thing is I need to see how big something like that gets. And I need to remember my SQL because it's been a while. Options. Is it generally important to run pragma for performance reasons? It's very important to use set the WAL pragma. Current reading and writing from an SQL data can be very slow in some cases, since concurrence is usually very important. WAL, journal mode. Transactions that involve attached databases are atomic for each individual database, but are not a common result of the set. Val file may experience the checkpoint starvation. Some hardware system may affect some users. Okay, definitely something I need to research. Sorry, I have an itch here, and I scratch, and then it just comes back. And then while I stretch, I feel like I'm dislocating my shoulder. I'm getting old. I'm getting old. Let's ignore this for now. How do we create a database? DB prepare. New database. How is this? I have a feeling this is not equivalent to this. It's not just... Okay, let's just see what this looks like. If I say new database, const options equals for now, because I don't know what these options could or should be. Is there anything here? API documentation. Does this? Okay, so I was just curious if this would just redirect to SQLite 3 and it's like, oh, we're the same as that, so just use that. What are the options? Options, database, new database, path options. Okay. Passing memory as the first argument. Okay, in-memory database might be a good start. Actually, no, we want to see what it looks like as a file. Options, read-only, file must exist. Timeout. Let's get a busy error. Okay, verbose. Provide a function that gets called with every SQL string executed by the database connection. Default no. Okay. Native binding. If you're using complicated build system that moves, transfers, or concatenates each data, it might have trouble locating its native C++ add-on. You get an error that looks like this. You can solve it by using this option by the file and path. Okay, I don't have a build system, so that's fine. Verbose console log. Sure. Let's try that. Verbose We'll just do something like that. Like if I do this, right? Database is not defined. Okay. I'm guessing I didn't pay attention where that came from. Ah, database from, okay. So I can do const database equals. But first, let's see what SQLite actually is. Is it just a list of things? Or is it function database, function database? Ah, okay, so database isn't... Okay, so SQLite is database. All right. So... Oh, I need to pay better attention. So this is the function that creates the thing. So I have to use this syntax. Okay. So I have to use this syntax, not this syntax. Okay, gotta pay attention. Hey, look at that. Okay. No. So that should have created a foobar DB. Okay. And foobar DB should be very small and or empty. All right, it's empty. SQLite file explorer. Can we just open that? DB browser for SQLite. Windows XP. I think this. I guess that should do the trick. And I think we can probably just do this. Now it's an empty file. Okay. So, now we need to create some sort of database, and I have to remember how to do that. And let's see. So this doesn't look very async. Actually, I'm gonna just do this. And then we'll just do something like show tables. Now the thing is, I'm used to MySQL. So some of this stuff might actually not be raw, pure SQL syntax, and it will probably fail without... Yeah. So show tables is MySQL, is not SQLite. Okay. And I'm gonna install this DB browser, because it'll come in handy. Wow, I can't believe I've still not made a SQLite project. That's crazy. That's fine. That's fine. All right. Yeah, well, wiser and older. Is it gonna install, or is it waiting for me to press a button? Yeah, it's gonna do that. Okay. So, to create a table, where do I go? Binding parameter class database. API. Statement. Binding parameters new database. Verbose. So it creates an empty database. Creates a new database connection. Okay. Okay. Now, how do we create a database? I mean, the database here is created. How do we... Transaction files were called in an error. How do we define the schema? Like, I'm used to create table, right? Yeah, of course. This is a database which can have multiple tables, I presume. Okay. New database. Create table. Is that just standard SQL and I'm barking up the wrong tree? Backup serialize function, load extension, exec, close. What if I do something like SQLite create table? I mean, I guess it's just standard SQL syntax, and I'm probably not gonna remember this very well because it's been literally decades. Oh, yeah. Oh my gosh. I wish I had some of my old SQL to look back on. Come in at 12 minutes, stalled the car, jumped in, just went back to start and realized this is way above me. Other spacing, I do have other spacing ideas. We'll send email messages. No worries, no worries. No worries, no worries. I'm here for it. Okay, so I want to create a table because we want to link it to our data here. So ideally, we are linking it to one of these object IDs, right? And I guess this string is enough. I was thinking of linking it to the short IDs, but short IDs can disappear. These should not change. Right, so we want to do create table, integer, primary key, ascending, YZ. So if we do something like, can I get the full syntax here? Okay, so we'll just do a prepare, or how are we supposed to do, create that? Do I have to add Node.js? Node.js. How to get a SQLite 3 database in yada yada. And yeah, don't tell me to use some other thing. Go. Error creating table. How do I execute it? db.run. All right, so we'll do. So let's do a try catch here. Catch error. All right. We'll do that. Gosh, darn it. Okay. Then we'll do let res equals await db.run. Something like that. If I just do that, how bad it's gonna be? db.run is not a function. Okay, so db.run is not a function. All right. So, is it prepare? Statement run. Prepare executes the prepared statement. So do we always have to use prepare? I'm already regretting going to something something non-standard. Open, read, write, error message, create table. Variable create table. So it's exec. Exec. Is exec async? Exec. Database exec. Executes the goodness. Unlike prepared state, this can execute strings that can be able to. This function performs worse and is less safe than using prepared state, and should only be used when you need to execute SQL from an external source, via file, blah, blah, blah. Okay. You must roll back changes manually. Okay, fine. Process dot migration. Close the database connection. After invoking this method, no statement can be executed or execute process dot annex at db close. All right, fair enough. So that should work. So now our file here is 8 kilobytes. And we had a tool. This tool. So if I now move that file onto there. Okay, XYZ. All right, so that works. Okay. I'm really just like rediscovering SQL because it's been so long. And I used to really enjoy it and I used to be pretty good at it. Do I have SQLite? No SQLite. Show tables. Is there such a thing as show tables? Or is that a MySQL thing? Database, select name from SQL master where type is table. db.all, select name from SQL master. What? DB, you have to use db.all. What is db.all? Wait, what did I just press? db.all. Run db.all. All. Okay, I don't want callback. Or get, such as all. All. Runs the SQL query with the specified parameter and calls the callback with a... Okay, and then you'll do select name from SQL master where type equals table. Is that something I can do with db run? So if I do something like let res, and get rid of this. Let's make this a single line. Maybe we'll do, we'll just do this as a label here. And I don't know if exec is async or not. So if I don't do a wait here, what happens? If I do this. I do this. Table T already exists. Okay. Create table if not exists. If not exists. Okay. And okay. And then we'll do the same thing with here. Select name. So select name. And then we'll just do select name from SQLite master. And always capitalize the SQL. Don't ask me why. Them's the rule. Table. Don't know if we need a thing at the end. So now we're doing exec again. Let's see if that works. Table should be a string literal in single quotes. Okay, so it doesn't like double quotes. Interesting. Okay. Look at that. All right, so it's finding... It's giving me the database back. What? Open, select name from SQL. Select asterisk. That's weird. Why is it giving me the same data on a... Okay, let's not execute this one. Skip that one. Okay, so that doesn't give me anything. It doesn't give me a result. Executes is unlike prepared setting. This can execute a string that contains multiple SQL. This function performs worse. Oh, it doesn't give me a result. Okay, I don't understand this API then. Run. Okay, run goes with prepare. Run goes with prepare. Get all. Area of rows. Similar to get, but instead of only retrieving one row of matching rows, will be received return. Okay, so get executes the prepared statement, completes and returns an object that presents the first row. So we need to probably do get. Can I do .get? Exec get is not a function. Exec before was returning this. Wait, what is this? What type of thing is this? Is that a string? Why is it returning a... No, it's returning an object. So I guess get doesn't happen after... Okay, well, let's try prepare and dot all. Right? That should be something. Okay, it exists. What's the result? Okay. What if I do remove this and just get everything from SQL master? All right, it has one object in a table, yada, yada, yada. Okay. Let's create another table. And then let's add a bunch of stuff. And then see how much data how much space that takes up. Is there a function of size? Because it's already 8 kilobytes. So let's do another create table here. And let's this time think a bit more accurately about what this thing should look like, right? So we'll have something like well, we'll call it puzzle counters. Or maybe solve counters. Solve counter. Plural or singular. Solve counter. Let's do that. Counters. I don't remember. H from cats. Yeah. Plural, right? Now, if we want to make it compact, we'll probably want to encode this as a hex string. How long is this? Or MongoDB object ID. How big is a MongoDB object ID? 12-byte object ID. Okay. All right. And SQL 12-byte. 12-byte buffer. Type. Decimal or big int data type. Big int requires 1 byte less, 8 bytes. 12 hex digits type. Except it's 24, I guess, if it's 12 bytes, right? So if I take one of these, this should be 24, yeah. 24 var binary 8. Okay, so we should be able to do something like puzzle ID, puzzle DB ID, and it's not var binary, so SQLite types. Okay, so now integer blob. Can we use blob as an ID? Blob. The value of blob is searched as more than general than a database. Integer stores, for example, 7 different integer types. More general than a data type makes a difference on disk, but as soon as the integer is related to disk, into memory process, they are converted to most general data. 8-byte sign. Okay. Boolean data type, type infinity, column affinity. Okay. I'm just trying to see. Can I do it less than 24 characters? Probably not, unfortunately. Int, small, medium, big int, unsent, big int. Text. Varchar. Varchar. The question is, could I... no data. Can I do... sorry, I'm rambling. The question is, can I store it in 24 bytes rather than... Sorry, in 12 bytes rather than 24 characters? Because that's over 16 million rows. That's going to save a lot, right? Numeric real no blob. SQLite blob ID. I use the primary key in SQLite. Values. Primary key works, text items, which are not very long, also work fine as primary key. All right, SQLite text or character range. Character range with, like, can I store between 0 and 255? SQLite binary type. SQLite hex. So it probably should be blob, but I'm also making myself a bit crazy. So let's do the test first. So let's just call it whatever, varchar or whatever we found as a, or MongoDB object ID stored in SQLite. Yeah. Nobody's ever thought about that. I would like to primary key together. I'm thinking about storing it as a blob. It seems possible, but there are any performance penalties compared to storing the hex value as a string with fixed length. Okay. Where did I just find the list of types? Was it here? All right. So if we'll do this and we'll make it a blob, can I make it a fixed length blob? SQLite fixed width blob. I don't know. How do I define a fixed width blob? Type column contains string star clob. What's clob? Character large object. We could try to store it as a 12 character char. The problem is the encoding. But we can test that, right? We can just store the values from 0 to 255 and see how that goes. Okie dokie. So how about we'll do character 12. So I say character 12, primary key, and then Y and Z. And these haven't gotten any types. What, yeah, before I do this, how do I get more information about these? SQL table name. So if I do something like, and I can just do that, right? Select S from T. Did I do that? Yes, I did. I have that up here. So there's nothing in there. Okay. And if I do in between, I'll do a insert. Oh God, I need to remember. SQLite insert. What does that look like? Insert into T. And then we'll have, what were our three things on T? X, Y, Z. So we'll do a 1, a 23. For example, I don't know if that'll work because I didn't provide types. Near 1. Syntax error. Oh, okay. X, Y, Z. Values. Right. Does not return data. Use run instead. Okay. Dot run. All right. X, Y, Z. Okay. If I do this again, we'll blow the constraint. That's understood. Let's just single line these. Oop. Right. You win. Okay. Select from SQL master. SQL show SQLite show column types of table. Pragma table info. Ooh, Pragma is the preferred way to query information. Execute select name type from Pragma table info. The command returns a list of dictionaries. Select type from Pragma table info. Table 1. Oh, okay, that's the prepare substitution, I'm guessing. So if I do this, and then this would be T, right? I don't think execute will work. Does exec work? Okay. Database from Pragma table info null. Why is that null? Isn't the table T? If I do prepare, and then I'll do .run. .all. Gosh, I sometimes forget how much. Okay, so these have no types. Don't even know what that means. SQLite, no type. Don't split the data. Yeah, what happens? For SQLite, the type is not required. If not, the default type affinity will be blob. Okay. Okay, so it just stores it as a blob. All right. Cool. Okay. I'm starting to get some basic tools of how to query this. Can't believe I've never gotten this far into SQL so far. It's insane. Okay. So we're going back to here. We want to create a table. We want puzzle blah 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 ID primary key. And then so we'll have I'm almost tempted to have a mapping from object IDs to some smaller integer ID just because those IDs are big. And we only have like 60,000 puzzles, so probably a 8-byte integer or something, and then doing a mapping table might actually be more efficient. Because let's think about it, right? We'll have 12 characters per row. So if I have a count of 1,000, that's already 12 kilobytes just for those IDs, right? But let's see what this looks like, right? So let's just say we have puzzle dbid, and we have a count value, which is an int. Was int a thing? Was int a thing? Int, integer, root, blah, blah, blah. Okay. If we do this, it doesn't like it. Probably because of this trailing comma. Man, let me have trailing commas. Come on. Okay. SQLite get table size. That's interesting information. Pragma size count. db stat from some db stat from inner join db stat on dbstat.name. What if we just say all of db stat? So if we do select asterisk from db stat, if there's a db stat thing. Ah, look at that. Okay, so we have SQL. Okay, that's now it's getting interesting. We have a schema. We have the T table, our test table. We have self counters, which I've just created. And we have auto index self counters 1. Interesting. And then page size this. What does it sum? Name equals where SQL master table name equals table name. And sum pg size. dbstat.pg size. Ah, okay, so these are the sizes. Okay, so this is where the data is stored. Okay. So, now we should be able to just insert a bunch of stuff and then look at the data afterwards, right? So let's do this twice. And then we'll just do a bunch of inserts. So for let I equals 0, I smaller than 100, I plus plus, and we'll do a console time, console dot time insert x100, and right. So we want to, where did you just put that? It goes here, you dummy. So, let's have another look. SQLite insert. How do we do insert? We just do an, I think I want to put Node.js here. Node.js. So do we want to do an exec or we do a run? So run. All right. Insert. So we want to do a execute. DB. So wait. db.run. Insert blah blah blah. And now that we're using better SQL, insert is that here we go. db dot so we can do something like this. Let insert SQL equals or statement equals db dot prepare insert into solve counters values and what are these weird ats and what's not? They're equivalent. Okay, so we'll do at id at count, right? Oh wait, well we won't have a count number here. I'm just realizing because each entry, we don't actually have a count. We'll have a date or time. Date time. Don't know how big that'll be. SQLite datetime. Tell me something about this. Datetime. Okay, that's not super useful. SQLite datetime size. How big are they? Oop. One of the proper features is allowing to choose the storage type. String comparison gives valid results, stores fractions sections up to 3 decimal, needs more storage space. You will directly see its value when using a database browser. Real number, high precision regarding fractional sections, longest time range, integer number, lowest storage space, quick operations, small time range. Possible year 2038 problem. 2038. Do we care about that? Okay, how do I tell it to use this particular date time? How? Storing dates or times, except it does have a date and datetime types, which are never mentioned in documentation. Anything including datetime is declared type of a column. Based on that, it gives the column an affinity with a storage class. It even has an example of how this works for datetime in the documentation. The affinity is more like a hint. Each of the column can actually have a different storage class. A storage class is still a step weaker than a type and can be backed by multiple types. State type, no, it does not actually support it as a type or storage class. Yes, the documentation actually contains the word datetime. Oh god, this is more complicated than I anticipated. I prefer simply things. Very, very simple. Down to seconds stored in integers. Integers will always be supported as integers in databases. Flash by that. You do a little math and cast it to another type. Yeah. Problem is, now we have time zones. Okay. Node.js better. Datetime. How do we store dates and times? I don't want to store it as a string. I want to store it as compactly as possible. If I go back to here. Ooh, it doesn't say anything about that. Don't date. This one download world. Guess because we didn't. So it doesn't have a datetime storage type. I want to start as a string. Created between word that not having a true datetime column. Okay, one of the powerful things. Own datetime conversion functions. So, SQLite supports 7 scalar date and time functions as following. Time modify. Okay, function returns the date and time format, yada yada yada. Subsect modify is used. Okay. Select date. Uh-oh. Well, I guess if I take the JavaScript time and just convert to a number. Okay, so how do I... The date time integer. How do I tell it to store it as a integer? Okay, blah, blah, blah. We suggest you stick with format as it's both C# and Android compatible. Yeah, I don't want to store that many bytes. All right, before we do this then, I want to also drop the table. So we want to do drop table. So drop table. Drop table if exists, solve counter. So SQLite, Node.js, SQLite, drop table. How do we drop a table? If exists, table name. I don't think we have a table name. If I do this, no such label. Oh, that's supposed to be in here. Okay, so we've dropped the table. And now we can create it again. And now this time, instead of a count, we'll have a dt date time. And how do we tell it how to store? SQLite date time storage type. How do I tell it? Don't make me rediscover how create table syntax works, because that would be so annoying. Date and time. Date time now. Insert into D1 text. I don't want to store it as a text. Int. Do I literally just store it as an int? All right. So if I do this as an int, right? If I do this, and sorry if this is going slow. I'm literally haven't touched SQL in at least 15 years prior to doing anything with video games. So with the schema, we have T solve counters, Select asterisk from DB stat. Create table, primary key YZ. Let's get rid of the T table. Let's get rid of it just to make sure it's not so spammy. So let's also stop these from spamming us. Okay, so we have this guy. We have a 12 character ID. We have a datetime integer. Okay. Let's do 10 of these just to get started. Right. Insert self-country values. ID. DT. Right. And then somewhere along the lines here, I had a page open with what that syntax should look like. Okay. All of this is super confusing. Nope. Insert integer, and then we'll do run. Okay, so then we'll just do this. So run is synchronous. I'm still a little confused about that. So if I do this, insert into people values, name question mark. Is mixing anonymous parameters with named parameters. So name. So the age would be 45. Okay. So what do we do here? So let's say blah blah blah. Let puzzle ID equals blah. And the puzzle ID is now currently supposed to be stored as 12 characters. Okay. We don't actually want to do this just yet. Puzzle ID X. Right? And we also want to output it, convert it. So parse int 16. Does that work? No. So what we do want to do then is dot split like that. Split it in sets of 2 characters like that. Match G. All right. I think that gets us all of these. 66. Yeah. Okay. And then we'll do map x parse int x 16. Okay. And now if we want to convert this to a string, we'll just say, JavaScript, blah, 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 code point to character, string from code point. Is it from code point? From char code. What is char code? Return a string from the specified sequence of user code units. Sequence of JavaScript character from ASCII. Is that code point? String from char code. String from char code. So if I do this, does that do the trick correctly? Or do I? Okay. And if I take that and do dot split, so that would split into individual characters, right? And then I'll do map chr to char dot chr dot code point at 0. And if I do then do string 16, is that is that 100% the original string back? 66, yada yada, if 8, B 33, CCB. So if I then do dot join like that, these should be the same. Okay, so this is the full reversal one way and the other. Okay. So let's make a little thingy-magic, a little function. Perform magic for me. Oh, I wish I was half as fast as I used to be 20 years ago or 30 years ago. So, hex to str. So we want to take something of this and turn it into a string of characters. So it's basically that, right? So we'll just say hex. We'll match it into pairs of 2 digits. We'll map them into thingamajigs. And I think that's it. So now we'll have a function. Can take this thing here. And it'll turn it to a string. And then str to hex. Right? And it'll be str.split. And then basically this. Nope. Each character will take whatever ASCII character is, we turn it to a hex thing. We'll do a pad start 2 0. And then a join. Right? And then we'll just repeat that and reverse it and see if the 2 strings are the same. Okay. And if we replace the 6 with a 0 6, it still works. Cool. All right. Thanks. Appreciate it. So now we can take a string of hexadecimal characters of and turn it into a string, an ASCII string. Now this is not safe, so I don't know if this will work. They might reinterpret it as UTF-8 or do some weird stuff. We'll find out in a second. I am not familiar with SQLite, so we'll see. If it works, then we're done. If it doesn't work, oh well. We'll have to think about how we're gonna do this. Okay, so we want to go back to the insert stuff. Here, right. So now we can just do this. We have these with ID and DT, right? So we'll just want to do that. Apparently this is not async. I guess it makes sense since it's just single threaded behind the scenes. So now the ID should be, and then we'll just say puzzle ID hex is that, and puzzle ID as what's the type character? Char equals x2 string puzzle ID hex. Boom. Right. Let's just output these to remind ourselves what we're doing. So the ID is this, and the DT is new date. Maybe that'll just work. Who knows? Let's see. All right, doesn't like that. Strings, begins, buffers, and null. Okay, so earlier we had a page open with something about datetime functions. Let's see if we can find these. SQLite blob columns as hex. SQL binary data type. SQLite date. So if I say new date dot value off unique constraint failed self counters dot that's not a unique. It's not a unique. Okay, all right. SQLite primary key non-unique. Non-unique. Okay, so it's not a primary key. So it's just a key. If I drop the table first. Okay, it's not a key. SQLite. You know what? I think I'm better off with this index. Nope. Okay. Node.js, SQLite, index. Let's see. Insert into. I should remember this, but it's been a long time. Username, select body messages, create table. Create table. Yeah, there we go. You can't process what you're asking. Create table, integer, primary key, blob, not no. How do I enter column? The table looks like this. But we index, and I would like it to be 4 bytes. Okay, so we need to add these separately. Did XX say it does multiple statements? Because if it does, then we can just do this. And we don't need a transaction for this. Create index. Puzzle ID on solved counters. Puzzle DB ID. Can I call it the same thing? We'll find out. You ask syntax error. Puzzle be character 12. Okay. So it's created these. They're slightly different numbers. So let us find our little SQL thingy here and put that in there and see what it looks like. Okay, so that works. That seems to create a bunch of entries. Now they're all super similar. Oh, yeah, that's our verbose function. I forgot about that. I was wondering where all this spamminess comes from. All right, that's good, that's good. So, now this is the idea. If we can create 60 billion of those and store them in a, reasonable amount of space, then we're golden, right? Let's see what this looks like without verbose. So we're currently outputting the create table result, which isn't really useful. Drop table result isn't really useful. Okay, so if I do these like that, then I don't have additional spamminess, because it's just outputting a string version of the object that gets returned, which isn't interesting. Yeah, okay, here we go. So now this is the contents of SQL master. So let's make that clear. Okay, and now we have our index here. And we'll want to do output dbstat before and after, and that should give us an idea of the size. And I think we can get rid of these or move them down. Actually, no, these are garbage. All right. So we have a schema, the counters, and that is that the index? Yeah, that's the index. Okay, so the index is basically a separate table. Fair enough. All right. And then we have a 496, 496, 496. Okay. So if I now do this times 100, and we'll just say let insert count equals 100. And we'll just do that. right? So now we're creating a 100. 365 milliseconds? Are you kidding me? Can we do it faster by telling it to not write to the table every time? SQLite faster insert. I mean, it doesn't really matter because this is not something that's really going to happen. Better SQLite. Insert per second. Every insert will happen in its own transactions. How slow? Yikes, 2 hours and 45 minutes. Only 85 inserts per second using a transaction. If you're finding a large number of inserts, it's advisable to wrap the operation in a transaction. Okay, so we can just do a begin transaction, end transaction. Okay, so let's see what that would look like over here. Find trans action. Creates a function that always runs inside of creates a function that always runs inside a transaction. When the function is invoked, it will begin a new transaction. When the function returns, the transaction will be committed. Okay, so wait, what? Transaction. Insert many. What? The transaction will be rolled back. Insert many. Insert many creates a function similar to this run thing. Transaction can be called from inside each other function. When doing so, the inner transaction becomes a save point. But we could also just do begin transaction. So let's try that. So it's 365 milliseconds. Let's just run it again to make sure. Yeah, 340 milliseconds. So it's over 300 milliseconds. So we should be able to do an exec, which should look like something like db.exec begin transaction. And then at the end here, we'll do an end like that. And now it's taken 4 milliseconds. And afterwards, what's the size of the file? 16 kilobytes. Because it just grows by page size, right? And we have 100 rows in here. Okay, let's crank it. So can we do 1,000? We did 1,000. Why has it got so many? Oh, interesting. So these are individual pages. I see. So the DB stats. Okay, interesting. 6 milliseconds, so great. And if we look at the file size, it's now 80 kilobytes. And it'll do that. Okay, so let us make a little helper function here. DB helpers. So the page size thing was that. So select from. So const get table size, and we want the DB and name, and it'll basically be this, something like that, from DB stat where name equals name equals name equals name. So then here, instead of doing this, we'll do that. Self counters. Oh, where'd that come from? if I do this, it'll do that. It'll do all dot map row dot bg size, or select bg size like that, right? And then we can just do object dot values. Oh yeah, we can do sum, right? Select sum. I forgot we can. I forgot that SQL is powerful. Hey, look at that. Look at that. Okay. And then we could even label it as size, like that. And now we can do that. We'll do a prepare. We'll do an all. We know that's an array. And we know it's got an element there. And we've got our table size. And we don't have any of the other stuff. Cool, 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 cool. So now we can get rid of these. And these. And we'll make it slightly more explicit here. Like this. Right. Oh, yeah. Okay, we don't need these anymore. I have faith in this. So, we can now insert 1,000 rows in 5 milliseconds. But 1,000 isn't the number to beat. The number to beat is whatever we found earlier. 16 million, right? And we're not going to go up straight to 16 million. We're going to do a few things in between. Let's try 100,000. So 100,000, 138 milliseconds. So that's perfectly acceptable. But now we are at 3.5 megabytes for 100,000. So that's roughly 35 bytes per row. So actually not too terrible. And that's the advantage of this over something like MongoDB or a JSON database, right? Let's go up to 1 million. And now we're starting to hit times where it just is going to scale linearly, right? Which isn't great. But again, we're not going to hit 1 million rows in production, right? And that's 67 megabytes, which is doable, which is okay, acceptable. The only problem is once we multiply that by 16, file size is going to start being a problem. And we need to kind of calculate for, ideally we'd have more information than just this, right? There are some ways of optimizing that. And we might just not be able to, what I'm considering doing is similar to what you would do with log files. So it's like you store that kind of data, let's say for 30 days. After that, you pull the data out and you archive it. And then you move it into, like once a month, you run a process where you take all the last 30 days of this logged data. By logged data, I mean 1 row per event, right? And you turn it into bucketed data where you then say, okay, what are the hits per day? What are the hits per hour, per minute? Even if it's per minute, you potentially save quite a bit. Although, considering it's spread across multiple puzzles, there will be relatively few solves in the same minute. So if I want to have minute by minute information, it's probably doesn't make sense. Even hour by hour might not actually make that much sense. Although it probably does. Okay, let us crank it to the full 16 million. And at the end, let's do this. Let size equals boom. And then console.log size per row equals size divided by insert count. And that should give us a good idea of what we're dealing with. Now, this being 16 times larger, this is going to be 20 seconds, which I'm going to have to entertain you while we're waiting for that to happen. It shouldn't be too hard. 20 seconds just flies by when you're having fun. Is there any other way of making it fast? Probably not, because this is not multi-threaded. This is not cross-browser. Yeah, 22 seconds. So we are getting to 36 bytes per row, and now our file is a gigabyte. A gigabyte? Damn. Is it? 36 bytes per row. That doesn't sound right. 36 times 16 million is 576. Why is it so big? And we probably can no longer just drag that into here. It's probably not gonna like that. Yeah. SQL DB browser. We just installed that. Can we do that here? Okay, this one doesn't have a problem. Local stuff. Cool, cool, cool. Local isn't dead yet. Why is it so big? Is it because the index? It's probably because of the index, right? So if we look, okay, so let's organize this a little bit. Let's kind of move the helpers up here. Helpers. It's just generic helper functions. Const test insert db. Right? And we'll just move all of this into the test insert. So that goes into this. This whole thing goes into the test insert. So we'll do a drop. Yeah, we have a drop table. Then we have creating the table. This is going to happen down here. Get table size. This can happen in here. We have these IDs. We have our little thing here. This actually doesn't make sense before. So then here we can just do test insert. So we can do that here. And now we're not going to do it. So we should be able to run this, and it should be fairly quick to just get us these stats, right? Insert count is not defined. Yeah. We'll pass it in. Insert count. And we can put that here. Actually, can I just time it here? Because obviously it still needs to load all that data and parse it. So it's not actually going to be instantaneous, even if we're not doing anything. In fact, we're seeing 1.2 seconds, which is probably the time just to open and parse the file. Actually, it doesn't parse the whole file, right? So what I want to do is I want to get the table size off the index. SQL master, yeah, because the index, okay. So can we do this for puzzle DBID? So we could have an index the same name as a table. Yes, I think the index or the primary key on that is the type and the name together. I hope. I'm not sure. Yeah, so the index is taking up the other 500 megabytes. And that's what's doubling our size, right? Because our index is so chunky. All right, so this is one of the... Hey, Mark. I don't think so. I mean, there's going to be per row overhead and all that stuff. Because the other thing we can do is we can have a link table, right? So I can have a table that just takes... And I could potentially do that in the MongoDB. I could have another smaller ID than this. Basically, just convert these to an integer. Let's test with that as well. So I'm going to copy this. And I'm gonna create a second version here. So we're gonna do test insert 2. And we're actually, yeah, I'm gonna wipe it because we can just recreate it. And we're gonna go down by, we're gonna divide it by 10. Hey, Mark, this is actually quite a technical subject, so I hope you'll stick around. I wish I could just, man, back in the MySQL days, 16 million rows wouldn't have scared me at all. But, you know. So what if we create 2 tables? The problem is we'd still want indexes on both, right? Okay, so let's create a table, if not exists, puzzle IDs. Let's do that, right? And then here we'll have a ID primary key and the puzzle.db ID. And we're not gonna do the second part just yet. I'm just gonna do that for now. Right? We have a primary key and we have this. And the idea is we'll probably still want an index on this, but basically this table would have one, it'll just convert these to something potentially more compact, an int. And then this table would only have to store that int, right? So it's basically just 2 ints. This still needs an index on this. I don't know if this index will collide with this later. Puzzle IDs, we'll call it that. And now we'll need to basically come up with some random puzzle IDs. So let's say we'll, 16 million divided 59,000. Let's just do 1,000 different puzzles, right? So this is 24 characters. So we need to create a const generate puzzle OID. So that's an object ID, right? And it's just gonna do this. And let's just skip this for a sec. I don't know if it'll actually take time if I'm not doing anything with it. If I do this, we want how many? 12? 24 hex digits, right? So, blah, 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 blah. We'll do a new array 24 dot map is that what we want to do? Math dot random hex digits. No. It's much easier if we just do this. Math.random times 25540. Right? That should give us 12 random bytes. And then we convert them to hex strings. So we'll just say do to string 16.pad start 0 2 like that. Dot join. Right? Yeah. And that should give us always 24. Oh. Should always give us 24. Am I doing the pad start wrong? Yep, I am. God damn it. I never remember the order of these arguments. Okay. So that gives us a random puzzle object ID, a random set of 24 hex digits. So if I do that, run that, I'll get some IDs, sometimes even leaving with a 0. Okay. So now let's create 1,000 puzzle IDs. So we'll basically do the same thing. And I think we'll do a second function here. Test create puzzle IDs. Count. So that's going to be very similar to this. So we're going to have a drop table puzzle IDs. And then we'll have this statement. Actually, we can just combine these. Like that. Right? And then we'll do something similar to this. Insert X. Whoops. Insert into puzzle IDs. Like that. Then we begin a transaction. And then we'll say insert into puzzle IDs values. Now, can we let SQLite auto primary key? We wanted to auto increment the primary key, right? So inserts, the row has a value of null. Insert values, auto increment keyword. Row ID selection item is used. The row ID is chosen for the new row is at least one larger than the largest row ID that has ever existed before in the same table. If the table has never before contained any data, then a row ID of 1 is used. Okay. If we do this, now how do I tell it which values we're inserting? Because here, okay, so I specify that here. So if I say this, right, and then we'll just say question mark, right? So that's our insert statement. And then here, we'll basically just create this, but convert it to our hex to string. Right. And instead of just insert count, it'll just be this. And that'll be that. And this isn't a thing. Okay. So now instead of this, we can do this. db and like 1000, right? And I want to see the size of puzzle IDs now. And we can just skip that stuff. Auto increment is only allowed on an integer primary key. Isn't that what this is? ID int primary key auto increment. There we go. It's only allowed for integer. It is is it integer? Okay. Wrong order in some weird way. Primary. Index puzzle DB ID already exists. Dip. Drop table if exists. This is not drop the index. Very possible. Type table type index. Okay. SQLite drop index. Let's see where we're at. Is that just like table? Drop index if exists. Okay, so we can drop index if exists. This one. Create index. SQLite create index. To be honest, create index. I'm not sure the syntax here is right. This might be the name of the field, and this might be the index name. And I'm suspecting that's what I got wrong here. Create index. Really? Well, they're both unique, aren't they? So create index. Create unique index. That's now the name of the index. That's the field we're indexing on. X.match is not a thing. Okay. X.match is not a function. Yep, because I didn't actually execute the function here. All right. So that gets us 1,000 free tables. Puzzle IDs. Okay. Can I view them? Indices. Browse data. Puzzle ID. Okay. No, this shouldn't be there. Browse data, puzzle IDs. Here we go. Okay. So now we should have something that's smaller. So now what we want to do is when we're inserting, we will first select from this ID table, and then we're going to pick IDs to insert. So we'll actually not execute this now. And in fact, initially we're not going to execute anything. We're also gonna reconcile these things a little bit. Drop table if not exist. Drop index if exists. We're gonna rename that. So this we need to change now. So this will gonna have a this is going to be a ID, puzzle ID, like that. And that's just gonna be integer. Integer. Right. And then we'll, ultimately, we also need to index on the date time. So the data is basically effectively going to get doubled. Because we want to be able to say, okay, give me all the puzzles in a certain week. So that's, ugh. All right, we'll see how that looks in the end. At least it's just two integers now. Can I just do int instead of integer? Let's see. So now we'll do solve counters underscore puzzle db puzzle ID on solve counters, puzzle ID, and create index dt on yada yada dt. Okay. And the table the index we want to drop are these. Now, we don't want to actually create these, run this just yet. In fact, we want to skip this for a sec here. And we want to drop some other tables here. So we want to do this. We want to drop a couple of indices. Table index, this one. So now we have one table, two tables, three tables, one index. This table we also want to drop. Drop table. Okay, so now, how big is our file? Did it get compacted? No. SQLite shrink file. Is there a way of shrinking the database? Putting SQLite vacuum. Always very helpful. Vacuum command repost the entire database. Okay, is that something we can execute from inside? Vacuum. It's supposed to be vacuum, right? Vacuum. Oh, it's like blah blah blah. Auto vacuum. So can we just do what we just did with the vacuum? If I do this, vacuum. Can I just do that? Great if I could. It's taking time, that's a good sign. But of course, it's basically just, yeah, it's just redumping the data. Now, it shouldn't be that big, right? Because, can I refresh? This file, none of these should be very big. Why is it still so big? Refresh. We have 1,000 of these, right? No. Wait, solve counters. I thought solve counters no longer existed. Oh, because I haven't dropped table solve counters yet. Whoops. Alright, drop table if exists, solve counters. If I do that, and then re-vacuum it. Why does the other table not exist? Okay. Refresh. Wait. How big is the file now? Still 590. Drop. Oh, table. What about the other tables? Okay, now we have no tables in here. And the file is 4K again. But where did these tables go? Very strange. Okay. So if I reinsert these now. Okay, so auto insert needs to have it written out as integer. Why? I wonder what the difference between int and integer is. Alright, if I do this now. How big does the table get? It shouldn't be too big, right? 76 kilobytes. Okay, that's great. Refresh it. Yeah. Browse data. Okay, so that's our primary key. Why is one of them written out and the others aren't? Oh, okay, that's some sort of auto recognition thing. This is a bit scary. I still have to confirm that these convert correctly. Although, if we're storing them like this, we could store them as a 24-character string. So we can just do this, and then not hex to string these. And we'll just do that. I think that makes sense now. So we just store them as a string. Yeah, it'll be a little bit bigger, but it won't grow very fast. In fact, it's 4 kilobytes bigger than before. So now we need to get a little bit creative. So we're gonna go in here, and we're not gonna do any of this stuff. What we need to do now is we need to make sure we're inserting counters for existing puzzles, right? So I'm just gonna do something like this. Let's just do that. Let's do console.log. And I probably should have done less than 1,000. In fact, let's actually do this for like 10. And then what we're gonna do is we're gonna do select from, what do we call them? puzzle IDs. Select, and then dot all, right? So if I do this, we'll get that, right? Can we do a random selection? Yes, we could order by random, right? We can do order by random. SQLite random. MySQL had a random function. Yeah. So we can do this, order by random. And we'll just randomly pick one from these, I guess. We don't even care. And we don't actually care about these guys. We only care about the IDs. So we'll just say ID from puzzle IDs, order by random. Whoops. And that'll get us this. .map ID to ID. Row. Your boat. Gently down the stream. Here we go. And we have a list of IDs. Okay. So let puzzle IDs equal this. And that's just our puzzle IDs. Cool. So now we can insert this many, and let's change it from insert count to just count, of our pairs using the integer puzzle IDs. Right. So we now have a puzzle ID here. We have indexes. We've dropped the table. We've dropped the indexes. We're creating the table. We're creating the indexes. We don't need that. We'll change this from insert count to count. Right. Insert. And we'll just do into self counters just so we self counters so we know what we're talking about here. Insert statement. Insert values. ID dt right. And the ID now is let ID equals puzzle IDs math.floor math.random times .length length floor that. Boom. And it'll insert that. And that will be a transaction. And if we're now running this 100 times, right? What does that look like? It, like this. dt equals, let's just do it like this. Boom. Okay. Now, this, is that an integer? I don't actually know. I don't even want to think about it. I'm just gonna find out. It is an integer. All right. Unix timestamp. Here we go. So after that, we have two tables, three tables because we have the SQLite sequences, and we have 1, 2, 3 indices, indi, and the table size of that is reasonable. Okay, and the whole thing took no time. All right, now let's crank it up. Let's create 1,000 IDs and 100,000 log entries. All right. 200 milliseconds, that's fine. We took 7 milliseconds for the IDs, 144 milliseconds for the 100,000 entries here. And if we look at it here, right? We can browse the data. That's our puzzle IDs, and then our solve counters are this. And then we should be able to map them to our puzzle IDs. And our file size is 4 megabytes. That's 100,000. Let's crank it to 1,000,000. It'll take a little longer. 1.7 seconds. Our file size is 45 megabytes. So that's 45 megabyte, 45 per mil, blah, 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 blah. 45 each, 45 bytes each. Which seems more than before. Ah, but that's total file size. So that includes all the indices and everything, right? So, if we go up to 16 million and let's say 10,000 puzzle IDs, what does that look like? And we're kind of rediscovering the joys of database normalization and why that stuff matters, and why the whole NoSQL thing is, you know, a little bit backwards, I think. It's kind of like, oh, the computer's so powerful, they can do anything. Until they can't. Until you struggle even with very simple things. Like, I'm just recording counters for puzzles, right? It was 1.7 seconds before. Now it's... Was it 100,000 or 1,000,000? There was 100,000. So times 10 and times 10. That's 100 longer. So that's a minute and a half. I might not want to do that. I don't know if this is gonna be IO bound. It even creates a little journal file. I wish I could read it. And it's like, it's growing relatively slowly. So I'm thinking the bigger it gets, the slower it gets. What's our expectation? 45 for 1,000,000. No, we did 1,000,000 before. I'm pretty sure we did 1,000,000. Is that 1,000,000 or 100,000? Where's the counter? Table size. This was... Yeah, it was 1,000,000. So it's only 60 times larger. So it shouldn't take too long. Only 23 milliseconds for the 10,000 puzzle IDs. I don't actually know what's taking it so long. Yeah, okay, so 450 would be 10 times, and we are 16 times. So 600 megabytes, roughly like that. So that's half the size of what we had before. And if it grows by 600 megabytes every year, that's fine, right? The only thing I'm not sure about with something like SQLite is, do I want to have a big file like that for a file-based, single-threaded thing? I hope there's not going to be issues with file locking and so on. In this case, no, this kind of database, I would never delete entries, right? It'll be write-only, because it's a log, basically. A record of the past, of what has happened so far. What I don't like is that it's so big for something this simple. Because in the future, I might want to add more metadata. Now, normalizing that would obviously be helpful. Like, let's say if we have user metadata, that instead of adding that metadata to each log row, you would want to create a user record and then, you know, link to it with an ID. Just like what we did with the puzzle IDs. Ultimately, probably this is not a sustainable system. So in the long run, probably what we want to do is kind of have, or let's say, have a 365-day detailed log, and then it gets archived. And then it gets kind of bucketed. So historical information is no longer stored in this kind of detail, right? I mean, there's simple things we could do. We could literally reduce the bit size of the date timestamp, right? We don't need it down to the microsecond. You know, we could say, okay, we're storing to the nearest, we round it to the nearest second, things like that. What we should be able to do now, though, now obviously this data is garbage, but, so it was 2.5 minutes. Oh, that was painful. Okay. So if I do this, it shouldn't erase the data. Right? Yeah. So now I want to see if we can query it and use the indices, right? So I want to be able to do something like the select statement. And don't need that anymore. And what we want to do now is console.log. If I do something like this, Might want to be able to multi-line that. Actually, we can just do that, right? So we want to select something in a particular date range. And we're gonna have to do a bit of conversion here. So let's say let's start et equals new date. I should have made random dates in a certain range, I imagine. Let's just what can we do? What can we do? If I do this, I refresh that. If I sort by that, like what's the range of dates and times here? So if I copy that, and if I like grab this one, and I'll grab one that's just a little bit further down, this one, right? And I'll say new date, and that's our start date, end date. I think that'll work, right? Let's not do that just yet. Make sure we know what we're doing. All right, so these dates should only be a couple of seconds apart. Okay, so all right, we have a range of a minute and a couple of seconds. So, if I do, and let's not do dot all. I gotta make sure I don't read out 700 megabytes of data. So if I do something like this, and I'll say select asterisk from this. Limit 10. Like if I execute that, okay, that works. Where, and I have dt, right? Where dt is greater or equals to at start date. If I do that, that won't work. Value off, but that might work, right? Right. And dt is smaller or equal to end date. All right, so that should get us that. And now let me remind myself, SQL select count. Can I just select count asterisk, right? Select count asterisk. That should be 10 because of the limit, right? 8 million. Really zappy considering it's actually opening the data table. I mean, it's not parsing the whole thing. I guess that's the trick. 8 million. That date range includes 8 million? 6102 026. I do this. 2 million, okay. I do this. Count 0. 900,000. I just want a reasonable number that I can actually display. 3. 0. 09 08. All right, now we're down to 50,000. 079 078 21,000. Okay, so this already gives us an idea, you know. So in theory, we could probably group them. Like we could do some funky math and then group them by sets of 1,000 and so on. Yeah, it needs to include time because I want to be able to graph, especially like during an event, let's say a YouTube video comes out. I want to be able to graph when, like, I think it would be interesting to see how the solve counts correlate to the release of a video, right? So you definitely need timestamps. So you definitely need the time, yeah. But the point is, this is super fast. So the idea is, in the past, things like this, I've always managed to get them fast enough to have them be calculated in real time, i.e. every user hits the site and it makes the SQL query and it makes the calculations and it looks at the entire database and it calculates in real time the latest data. And if you know anything about this, then you realize that no actual system works like that. My systems always have, but any analytics system is never like that. They never do real-time queries against the actual real-time data. It's always delayed. It's like, oh, maybe it's to the nearest hour if you're lucky, sometimes to the nearest day, right? So in reality, probably what will happen is there'll be a process that runs maybe once an hour and takes the last hour of data and generates, bucketed data, like summary data. It'll say, okay, here is, instead of saying we have one entry per every solve, what we have instead is we have one entry per every hour and a counter of how many solves happen in that hour, right? So imagine you have a database where you say, we'll have something like, we have puzzle ID as a column, and then we'll have hour 1, hour 2, up to hour 24. And then, this will be our hex number, right? And then we'll have 0, 0, 1, 5, 3, 5, and so on, right? And then this table would, for example, be used for hourly graphs. And then something similar you might do for minutes, or not, right? Like there could be a table for minutes, maybe every 5 minutes, maybe 10 minutes, I don't know, right? Well, whatever makes sense. And this data could potentially be compacted, but I don't even want to think that far. And potentially this data only exists for the top 1,000 or 5,000 puzzles, like the puzzles people care about, puzzles that were done recently. And then puzzles that aren't in this table fall back to actually generating. This is kind of like a cache, right? So if that data doesn't exist here, it falls back and it generates this data on the fly, that kind of thing, right? So that's the other way of doing it. Instead of doing a regular process, you literally just build this on demand and dump it into a cache, and that cache contains the last X days of Y puzzles, So let's say it has space for 100,000 of these 24-hour lists, right? And then every time somebody requests per hour data for a particular date, it checks that cache. If it exists, it outputs it. If not, that kind of thing, right? All sorts of things can be done, right? I'll just have to think about it, mostly not for this specific use case, but in general in the future. I'd like to track more time-based information, So this could include things like how people interact with a puzzle, solve data, etc., right? Of course, that probably wouldn't be as frequent. Now, this 16 million is actually the total solve count. So that includes not just a year, but that includes count from almost the year before. So that might be about 2 years. So if I have to add a gigabyte per year for this, it's not a big deal. It's more like this is not really representative of what I would want to do with this, right? But right now it looks like this could be quite fast. Now the other thing we want to try is a distinct ID. So how many puzzle IDs are in that? Did I just leave that there? Yep, I did. No such column ID. Puzzle ID. Sure. Yeah, So for example, we have 4,562 distinct puzzles. And if I do this with, you know, counting just everything. Yeah. So we have 6,134 hits over 4,562 different puzzles. Which makes sense because we just completely willingly randomly selected the puzzles. But in reality, the number of distinct puzzles per day is going to be much lower. So if I look at plausible, for example, and I say distinct counter IDs in one day, okay, yeah, it could reach 1,000. But I don't think this is all of them. Yeah. I would actually not know, right? That's information I don't know. I don't know how many distinct puzzles would have gotten played in a single day, right? That's the other thing. Analytics, right? So I might potentially want to throw in have a similar table to this and then throw in a row with every time a puzzle gets loaded. And currently, you know, we have about, let's see, yesterday. So we had about page views, 71,000 page views yesterday, right? So if I want to add 70,000 rows, and then here the data would be bigger, right? We want to say, you know, things, I don't know, standard stuff like user agent, locality, you know, the standard log stuff, right? So you cannot have each row be multiple kilobytes if you want to store 70,000 of them every day, right? But again, you can normalize them and reduce that. So what did I want to do? Okay, I wanted to actually get a little bit more explicit with this. So let me do a limit. Okay, no, let's do this. Let's do this. We do a limit 10, right? Can I group them by puzzle ID? Can I group them? These are hundreds of milliseconds. So if I group them, I'm just trying to remember my SQL. What if I do puzzle ID dt, and then I'll say dt divided by 1,000 as dt sec. Does that work? All right. So if I do divided by 1,000, that's seconds. If I do divide by 60 again, that'll be minutes, but then they will all be the same, I believe. Yeah, because of the time range we're looking at. So obviously having more realistic data would be helpful here. In fact, they're already all the same. If I say, oh, geez, I need to remember SQL group by where group by dt sec or dt divided by 1,000. I think I can do that as well, right? So if I make this range a little bit bigger, yeah, in fact, it's the same thousandth here. So if I do this, okay, here I can actually control exactly how many seconds my query goes over, right? So because we want to group by dt second and we want to group by puzzle ID. So if we say select count distinct puzzle ID, $10,000. How would we want this? Because we basically want a three-dimensional structure, right? We want for each group of time and each puzzle ID the number of thingies. Okay, what if we let me just think about this for a sec. What if I do concat puzzle ID, on cat, puzzle ID, underscore, DT over 1000, string literal in single quotes. Sure, single quotes. Let's, okay, as ID sec. Right. So ID sec should now combine the puzzle ID with the time divided by 1000. And now if I group by ID sec, puzzle ID 1000. Ah, okay. If I limit to more, it'll look like this. We actually now we don't care about these anymore. Count. Is that what we want? We want how many entries are under that particular kind of thing, right? And if we divide it by... So thousands, those are the milliseconds. So we have a range of about 5 seconds here. Hey, babe. Let me think. Let's go back down to 08. The problem is we have so many IDs, right? But basically, this kind of would get us a graph, right? So that for each of these IDs, it would get us a graph for that period of time. So let's try something else. If we say where ID equals that, and puzzle ID is 10,000. So that only gets us 2. But if we skip the range, if we skip these, what does the query do? Is it just gonna blow up? Yeah. ID puzzle ID is 10,000. Right. But if I remove these two for now, so that gets us basically the graph for that particular puzzle per second. Again, because my test data is just the time at that moment. And now that we're not limiting it, we can also divide it by 60,000 to get it per minute. And then because we generated the test data over 3 minutes, we only get 3 values. And that's basically our graph, right? So this would be a graph per minute for the test data for this particular puzzle ID. And what I'm basically testing here is how fast does this run? And it runs very, very fast, thanks to the indices and the way index databases work. So from a cold start, opening, like there's no server running, opening this 800 megabyte file, we can use the indices to get that data in there in fractions of a second, right? Yeah, in less than 100 milliseconds, right? 60 milliseconds. And a lot of that is probably just setup and logging and all this sort of thing, right? So this is definitely feasible for what I want to do in terms of I want to be able to have an API that you hit and it hits the database and asks, okay, what's our stats on that puzzle for this time period under these circumstances, yada, yada, yada. Now, that's not something I want to expose publicly. So it's still something I would at least put behind a cache but initially also behind an admin API, right? And yeah, and I think performance-wise, this is absolutely not a problem, right? Like, we saw how fast I could do 16 million. At most, it'll be 70,000 in a day, and that's obviously not gonna happen. I don't know if I have an idea. Yeah, I do. I can actually filter by puzzle solved, and there are roughly a max of 23,000 a day. So, so as long as the database can handle 23,000 inserts in a day, not a problem, right? And if we add 23,000 every day, 23,000 times 365, we'll get 8 million. So half of the 60 million. So our expected growth is less than 10 million entries per year. And anything that I can, like, say, okay, I've got 5 gigabytes dedicated to it, that'll set us up for 10 plus years, you know, including some growth, is fine. Right. So that's, we haven't done any of the front-end work, so this is all me messing around with SQLite. But to be fair, this has been a lot less painful than a lot of the other systems I've been looking at and trying out. So I'm actually super happy with that. So basically, what I would want to do, though, is initially I would run this in parallel with the existing system. The trickiest part would then be to know which data is double counted, right? Because let's say a puzzle has 1,000 solves. Now I start counting with the new system. The problem is, I know I can add 1,000 solves now to get the real solve count to the new system. But if I run the old system, if I continue to run the old system, now eventually the old system will reach 2,000 solves. I no longer know that it was 1,000 solves when I started the existing system. So I think I'll run the old system as backup. But at the moment I'll make this new system live, I can no longer use the old system as my source of data for the old data, right? So at that point, I basically have to export the old system into a static repository of some kind, probably an SQL database, right? So then basically there'll be a table with current data in it, right? In fact, what we might want to do, where is this one, right? So what we actually would want to do is counter JSON. The counter is not here. The counter is in another castle. So we're going down 1, we're going down 2, and then it's api.sudokupad.com / right? And we'll do something like console.log counter JSON object.entries length. And I'm very happy that it still runs this quickly, right? So we'll basically have to take what's in here and bring it into here. Now, the data isn't super compatible because the old counter database is based on counter IDs, while this new data will basically be based on the actual puzzle data, which is linkable to the count. I'll have to figure out I don't know yet exactly how I'm gonna make this all work. Probably what I'll need to look at is how many. Yeah, so for example, we could probably look at the distinct number of counter IDs, right? And for example, there'll be a lot of dashes, right? A lot of counter IDs that are just the dash. Let me see if I look at the counter API. If I say, all right, show me the API, right? If I look at this, open a new tab. And if I now just say, okay, just give me everything that's only a dash. 156, so that's obviously not it. So there's a bunch of these guys where it's not just a dash. Is it? It looks like that's just a dash.
I would find it strange that that's the total number of counts for all of these weird puzzles. Maybe they don't get played very often. I don't know. What about blue dot sort? A, B. If I do this, A 0 dot length minus B 0 dot length, dot slice 0 10. I just want to see what sort of the 10 shortest count IDs look like. Yeah, so there'll be a whole bunch of garbage like this, but there are not actually that many counts. Like, I would have thought that some of these numbers would be really big, especially the dash one, because a lot of puzzles would collapse into this ID, similar to the no name and so on. So what we could also do is we'll do the inverse by counting, looking at the largest counts, which are most likely to not be any significant puzzles, but instead, not length. Yeah, so unknown untitled is by far the biggest count because all puzzles created in F puzzles that don't have a proper thing set collapse to this. But I'm happy to see that most of the counts seem, other than that, seem to go to real puzzles, right? And if I look at a longer range, they still all look like they're fairly large, fairly long IDs, which usually implies that they're likely to refer to a unique puzzle. Unknown little killers. Yeah, even that. So what if we filter by... Let's see, what if we do filter... so we have ID CNT. We filter by ID.length is less than 10. Like, if we filter by shorter IDs. Because that's probably where we're going to get a lot of the broken ones. But even here, the largest counts, A, are still real puzzles. Except maybe for Zegras Dash. We can have a quick peekaboo in that. If we go author, just pick one here and filter by Zegras. Zegras. Apply filter. And 6788. If I... Oh, wait. How many solves are there? A lot. But I don't actually see that many... because that's by 1 day. All time. So he's got 6,788 on a puzzle that doesn't have a title that doesn't convert to a good puzzle ID, right? So some of these puzzles are pretty big. Let's have a look at what titles there are. And Toby. Is that... I think that's a puzzle he made for me. Oh, that's why it's called N Toby. Toby, there's a puzzle named after you. Ish. Well, because it has the name Sven in the puzzle and then N Toby as the title. Toby, there's a puzzle called N Toby. Oh, I wish you could just solve Sudoku. But that is not the puzzle that is creating this counter inconsistency. Let's go back to here. There definitely would have to be a title that's not... that doesn't contain... it's probably something like this. Because these are weird Unicode characters that I filter out for this ID purpose. Probably this as well. So it's probably a bunch... Like, he probably likes using these... yeah, probably this one as well. How many did we get? 6,788. So it's definitely this one. It's 1.7 thousand. This number might be smaller than the counter number because the counter like started more than a year before I started logging into Plausible, because that's just from like 2024. Huh. Interesting. Anyway, we're doing a... Yeah, so the real... Usually tests are done on an unnamed untitled grid. Yeah. And unfortunately, it's going to be a bit tricky to reconcile the old data with the new data. And I don't know if me trying to do that is a good idea or if I should just have a clean split. I don't know. The other thing I'm thinking about as well is, for example, if instead of each individual hit has its own entry, I have a counter, but it's just more granular. So I basically have a counter for each minute, right? Even if the counter is a 1 most of the time, right? It would probably still save database space. And then I could just create a counter equivalent to the current count for the first minute that I'm running this. It'll screw with the graphs, you know, or have a special time where this counter number is, right? Yeah. But probably what will happen is... The other thing I could do is that only new puzzles get into the new system. But I don't like that either, because a lot of existing puzzles will still continue to collect traffic and so on. I mean, the solve count is not super prominent in the current site. So obviously, once I build a better system, it might become more prominent. And I'll probably be collecting new data for months before the data will become more publicly available, right? So this is mostly in preparation for later on when I have like an account system and stuff, and setters want to see data about the puzzle. And I'm hoping that I'll have collected multiple months of data by then. Yeah, I'll have to figure out exactly how I'm going to do this. Now, I need to do this not while I'm programming. I need to do this with pen and a notebook under a tree somewhere, so I don't get myself distracted. I find it very hard to do bigger planning while I'm writing code. I get sucked into the minutia of getting it to work. And I'll probably want to build this independent of this. So I'll probably want to first build this just substituting the current API, but using the same storage system. Because currently the API is literally running on a different server software. It's running on the api.sudokupad.com on a different host. Well, it's the same server, but on a different domain name. So I want to do that first. And I'll probably might set this up in parallel just to start technically testing it without necessarily worrying about how I'm going to reconcile the data, just to see, hey, how big does it get? How fast does it grow, you know? And I can always say, okay, I'll make a backup on that day, so I can always retrospectively figure out what the counter data was at that point in time. I think that's probably the smartest thing to do. Give me one sec. All right, Toby's going on his walk. He's a bit tired. He had a long week. All right, I think I'm gonna wind it down. I'm getting super tired. What time is it? It's 8:30. When did we start? I don't even remember. How long have we been going? Almost 3 hours. Yeah, I'm getting super tired. I'm super happy with the progress, even though I've mostly just poked at SQLite. But, you know, we got all the basics. We're creating tables, we're deleting tables, we're creating indexes, we're querying databases. Because I know that some people were making hourly backups of the counter data, so I can get a per hour set, potentially retroactively for the whole year. But this format doesn't actually support that unless I generate, like, you know, if there's a counter of 100 for a particular hour, I could create 100-hour entries with the same hour as the date time. So maybe I don't like this after all. The question is, do I want to keep this format as well, this sort of logging format, and with the goal that it gets archived, etc.? Or do I just skip past it and just say, okay, we have buckets, right? We'll just have we have counters for every minute of every day, for every puzzle, that kind of thing, right? I don't know. And they could be optional, right? So 0 doesn't necessarily have to exist in the database. We could simply say, hey, we're getting a hit. Round it to the nearest minute. Does that row exist? No. Create it. You know? So we have sparse data. We still have the benefit of sparse data, right? And if it does exist, you know, increment it. So that might be another format to do it in. I mean, I'll never need more than hourly, minute per minute, what's the word? Resolution, right? The other consideration I have is that if I have per event data, it's much easier to fix the data retrospectively if something happens, right? So for example, if a counter goes up by 20,000 and it happens within a few seconds or minutes, it's much easier to filter that bad data out and know, oh, okay, somebody's spamming it, somebody's messing with it, right? Versus if it's in buckets, I mean, if the buckets are small enough, you can still sort of do that, right? If you have a massive spike, you can just shave it off, right? But with this, I'll potentially add additional information to it, right? Maybe an IP address, I don't know. Then it'll be definitely easier to say, oh, okay, somebody spammed it, right? And that would be attractive to me to actually have that capability. We'll see. All right, yeah, today was a bit of a techie stream. Sometimes that happens. I'd like to try much harder to make the streams into feature streams where I plan out ahead of time what I'm building and then build that and make sure it's small enough that it fits into 2 to 4 hours. Which means I might actually pick another day of the week and create sort of research streams where I do stuff like this, where I'm just working. Like, you know, a long time ago, 8 years ago or something, I used to stream 8 hours every day. I just streamed my work. I'd like to get not exactly there, but have more streams during the week where I'm just messing around and doing things. Like, just don't worry too much about making the stream entertaining or making it cohesive. Like today wasn't really a great stream for my code hangouts. I mean, it's actually a good stream for a code hangout, but not what I want the Sunday streams to be like. I want those to be more like feature streams. And actually doing things that people care about and wait for. And I want to be able to interact with the setters for things they have asked for specifically, so I can say, okay, let me build that, right? Going back to here, to our little Trello board. Let me see. Yeah, so these actually are way vague, but like I'd like to have features on here that I can actually build. These are actually, a lot of these are much bigger things, like the admin dashboard and things like that. And feature planning stuff is also not very good for streams. I'll probably want to move that into separate streams or just not on streams. The stream should be more like the result of the planning, so that's kind of where I want to do. What I want to get to. You should have a mess plan. Yeah, exactly. Yeah, I mean, if you're curious, let me have a quick look at something like plausible. So if I say, So the on my time zone, the Cracking the Cryptic streams are usually late at night. And they're usually 2 spikes. So if we look for the last 7 days, so you usually see that 2 spikes off the Simon and the Mark video, right? Yesterday, not a big spike, surprisingly. So if we go into their YouTube channel and we look at the videos, so 9.7, 27K view for 20 and 22 hours ago. 9.3, 34. So 27, 34, like if you look at Simon's, 40. Right. So if I look at yesterday, and the problem is, I think 22 hours ago, right? 20 hours ago is like just, so one will be just past midnight. So the other spike is kind of here. One of them is, I think, exactly on my midnight, because I think this is, I think they're 2 hours offset from me or something. I'm not sure. So let's see which puzzle that was. So if we have a look at this fog puzzle, and we'll look at the ID 330KJ. So that's this one. Why is that the yeah? So sometimes the higher one is actually. So let's have a look at these two. Is actually from the day before. Because not everybody's seen the video yet, right? And it had more time to collect. Yeah, so this one would be the one probably from the day before. So January 2200, 5th, so Sunday 2200. And this one is Sunday midnight. Yeah, so this would be Simon's video, and this would be Mark's video. Right, so we have 6.7 total page views, 7.9 total. Yeah, so this one is higher. Yeah, okay. So that one would be my midnight, which is kind of annoying because it's hard to see it on the graph. I might have to offset my time zone. All right, so yeah, Mark is 2 hours before, and then Simon's is at midnight for me. No, wait. You're right. Which one is first? Is Simon's before Mark's? 22 hours, 20 hours. No, Mark is first. Okay. So this would be Simon at midnight, and then Mark would be at 2200s, right? Simon before Mark? No. 22 hours ago versus 20 hours ago. Oh, yeah, okay. Oh, you're right. Okay, so... my brain. So this would be Simon, 2200 hours. And then this one would be Mark. 9OS. So that would be this one, 9OS. Yeah, 9OS1. Okay, and then this one, 333K, 330K is this one. Okay, 6.7. So why does Mark's have more than... interesting. I think part of that is that Mark's puzzles are generally easier to solve. So if we're looking at this one, the average time on page is 50 minutes, while on this one it's 39 minutes. It's longer as well. That's bizarre. So Simon's 1.5 minutes, and then Mark's is only 10 minutes? Okay, I don't understand what's going on here. Maybe more people try attempt Mark's, and then more people just watch Simon's? That's super curious, actually. Because generally I have more page views on Simon's videos. Interesting. So maybe it probably changes. Like if Simon's are under an hour, then more people will attempt it, I think. Do you know when Bremster's video was? Interesting. I'm like, this is, I'd love to do this. I'd love to retroactively tag these with the videos and then say, okay, what's the statistic difference between Simon's and Mark's videos and things like that. That stuff is really interesting to me, actually. Okay, I feel like I'm no longer effective and I'm kind of rambly, so I'm gonna call it here. thanks for Chesco for stopping by. I really appreciate it. And I'd like to get all these ID things sorted out and figured out and improved and all that. But, you know, I can't just do... like, they might be simple on the surface, but because I have 4 years of stuff that I want to carry forward with me, and I don't want to abandon, it's a bit trickier trying to keep old data working and keep things that were imperfectly designed, as all things are, to improve them, you know, exist. I definitely think, here, we're a Japanese title, right? Yeah, I want imperfect things to be able to exist, especially with our puzzles, which are always imperfect things, because, you know, it's the whole ecosystem is a bit of a mess. But I really appreciate you hanging out. It always makes it easier and more fun to work on this stuff. So thanks for hanging out, and I hope you'll be next for the next one. Well, you will be back for the next one. That makes more sense. Thanks for hanging out. All right, take care. Have a good rest of your day. Bye-bye. Ciao, guys.